confirm whether my screen is visible to all of you so that I can teach all of you the design of experiments. Please confirm.
Yes, yes, it's visible.
I expect everybody to be participative, not just Rajesh, right? So if at all I have to appreciate someone, I should appreciate you.
Yes, sir. It is visible.
Right. So design of experiment is after hypothesis testing, after the analysis phase. In analysis, we have identified root cause. We have validated the root cause. We understood the relationship, linear, non-linear. Whether we will first check whether linear relationship will work. If not, we switch to non-linear. In non-linear, we check quadratic, we check cubic. Whichever fits well, whichever gives a better R square, whichever gives a better adjusted R square, I will accept that relationship and then proceed further in that direction. Proceeding further in the sense, I am going to generate the solution now. I know the root cause. I know the relationship of the root cause with the y variable. I also know the sufficiency. Sufficiency means R square. R square is 90%, yes, sufficient. R square 30% not sufficient. So I know everything about the problem, the root cause, and I can definitely now offer solution. And now solution is nothing but tuning the X factor. Why solution is tuning X factor? If I tune the X factor, what will happen to the Y? Y will get tuned. Y can be my rejections, Y can be my sigma level, Y can be my profit. I know what will happen to my profit when I tune a particular X factor. I want my profit to go up. I know the relationship is positive. So I increase the X so that my Y will increase. If Y is, let's say, directly a profit, then increasing the X will increase the profit, right? So when I optimize the X, Y will definitely get optimized. And that is what we are going to do it. So in the improve phase, a formal explanation about improve and control will be done in the afternoon. In improve phase, there are 3 steps, right? Because we are done with the 9 steps, right? And now in the 10th step, you will be generating solution. Then in the 10th step, you will be optimizing the solution. Optimizing the solution means optimizing the root cause. Optimizing the root cause means optimizing one or few of the X factor. You can do it in 2 ways. What will happen when I change the X? I can use a computer. I can use a software like CFD, Computational Fluid Dynamics. You might have known, isn't it? There are many softwares available. These softwares have the knowledge about the relationship between X and Y. So without doing experiment, you set the parameters, you set all the X. What will happen to your Y? The software will show. This is called simulation. All of you, do you understand simulation? What is simulation? Let us say, when I burn petrol inside an engine, internal combustion engine, how the petrol will burn inside the engine, how the fuel is converted into heat energy, how the heat energy is converted into mechanical work, which is rotation of the wheels. A software is already available. Software is already available. So this simulation software, when I set the X factor, let's say the engine pressure, engine temperature, the size of the cylinder, we measure in terms of cc, the cubic centimeter, 1000 cc, 1500 cc, right? And the air fuel ratio, all these are X factor. All of you get me? All these are X factor. I set all these values in the software. Now software will show me how the fuel is burnt, how the energy is developed, how the piston is pushed downwards. This is called a simulation. I have not done any real-time experiment. I have not done any real-time experiment. I know that 3 factors are critical. I only know that 3 factors are critical. The 3 factors are the temperature, the time, the turbulence. Because the quality of burning depends on the cylinder temperature. All of you agree? Quality of burning the petrol, we call it combustion. The quality of combustion depends on the cylinder temperature. Am I right? A warm engine can burn better. Am I right? A cold engine cannot burn. So temperature is one critical factor. Through hypothesis testing, I understood. Then turbulence. Turbulence is, the airflow. The airflow will have the turbulence. This is required to mix the fuel and air, so that, in the presence of air, fuel can burn better. All of you agree? So the second factor is turbulence. The third factor, time. When I give more time, more fuel will get burned. So I just have to make settings. I just have to make settings. I just have to make settings about temperature, time, turbulence, and other X factor. As a result, I could now judge on the fuel efficiency. So this is called a simulation. But when I do it in a laboratory, when I do it in a real engine test bed, that is called experimentation. All of you understand the difference between simulation and experiments? Please confirm.
Yep.
Yes. And see,
Yes, sir.
please all of you try to use all the options. There is a chat option, which Anand is very good at using the chat option. And similarly, there is a reaction. This also you can use, right? And you can see the reaction option, isn't it? You can show fingers and other things. So quick response can save a lot of time. This is called a lean thinking, right? Now, so there is simulation. There is called design of experiments. And I am here not to teach the simulation. I am here to teach you, understand the principles behind design of experiment, so that when DOI is required in your project, you will do it correctly. So again, when it comes to design of experiment, there are two methods. One is traditional method, other one is designed experiment. The main advantage of going for designed experiment is interaction can be detected. Interaction can be detected. If there is a factor influencing your Y variable, how many impact will be there? One factor can make only one impact. Am I right? One factor can make only one impact, which is called the main effect. Which is called the main effect. Suppose if there are two factors, how many effect will be there? If there are two factors, how many effect will be there? There will be minimum two effect. There will be minimum two effect, but there can be one additional effect, which is called interaction effect. I am teaching, there is an effect. You are learning, isn't it? And you are participating well. That is another factor. That is also important. That is also having an effect. If we all assemble in a classroom, do you think the effect will be much more in a real live classroom? There are only two factors, student and teacher. But when I bring one more component, which is real classroom training, we are able to understand, the outcome will be much better, because we can really have a face-to-face interaction. We can shake hands, we can exchange thoughts easily, and so outcome will be more. That means there is one more effect more than the teacher and the student, which is called interaction. Teacher and student, when both of them are present at the same time, that will have a different impact. So that third effect, which is called interaction, can also be understood through the DOE, which is not possible with the traditional approach. Let us say there are three factors, A, B, and C. Now, how many effect will be there? Effect of A, effect of B, effect of C. Three effect, three main effect. Then effect of A and B together, which is called AB. Effect of B and C together, which is called effect BC, and effect of C and A. AB, BC, CA. So main effect is three, interaction effect is three more. Then one more possibility, all the three together. All the three together, which is called ABC. So now totally how many effects? 7 effects. But how many factors? Only 3. Generally, even researchers, they think when they are controlling 3 factors, they think only there are 3 factors. But in reality, how many effects will be there with the 3 factor? 7 effects. All of you understand? So always interaction needs to be tested. Interaction can also be powerful. If interaction is powerful and you don't respect, then you will not be able to optimize, right? And I'll explain interaction slightly in a better manner in the upcoming slides. So objective of DOE is we are optimizing the Y. We are optimizing the Y by setting the X. By setting the X, we are optimizing the Y. I fix the coffee powder. I fix the amount of milk. I fix the amount of sugar. I fix the temperature. I fix the stirring time. I fix the skill of the chef. Now my restaurant is ready to deliver the tastier coffee in the world. The tastiest coffee of the world, I am able to produce by fixing coffee powder, milk, isn't it? Temperature and the sugar and the stirring time and the skill of the chef by optimizing the the cup in which the coffee is served. Everything I am optimizing. Even the mood of the chef I am optimizing. I wanted to see to that he stays happy while making coffee. So now the coffee produced will be the world's best coffee. This is exactly DOE. So I am determining where to set the influential X so that my Y is near the nominal. The taste of the coffee is always the world's best coffee. The variability is small. In every single day, the chef makes thousands of coffee. All thousands of coffees will have the same taste. The variability in Y is small. Do you think the chef could have done hundreds of experiments to arrive on the formula? Hundreds of experiments, isn't it? And those experiments, those learnings from the failure is now saving him. This is exactly DOE. And the chef has come to the level that the coffee is always the tastiest coffee in the world. Whether there is a rainy season, whether there is a sunny season, whether the humidity is more, humidity is less. In spite of all the factors which he cannot control, he makes sure every single time his coffee is tastier. That means he is not allowing the uncontrollable factor to influence his coffee. Do you understand? He is not allowing even the uncontrollable factor. He can't control rain. He can't control humidity. He can't control temperature. But he makes sure the coffee served to the client is always tastier. Do you think we will be able to control even the uncontrollable factor? Not directly, but indirectly. Outside there is a heavy, temperature. Sun is at its peak. I can still sit in an air-conditioned room. Am I right? Air conditioner, room temperature, I can control. But outside temperature, I cannot control. But influence of the outside temperature inside my room, I can still control. This is called, controlling, ensuring, this is called, preventing the uncontrollable factors to influence your result. You are making your system robust. Do you understand what I'm speaking? You are making your system robust. This is called robust design. Robust design means a design in which your system will not get influenced by even the uncontrollable factor. Just to help you understand one example, scratch-free screen. The screen is scratch-free. Even if you throw it onto the wall, the screen remains clean and clear. No scratches. Right? So waterproof screen. And these are, so water is there, water is coming and playing. Water has its own nature, but I still prevented the effect by making my screen waterproof. My design is robust design. All of you understand robustness here, the meaning of robust design? Let us make this DOE very, very simple. Let us take the example of making a birthday cake or making a cake. Imagine you are now you are planning to open cake shop in 100 plus locations. You have applied for a loan. Applied for a loan of, let's say 100 crores. 100 crores not required, 10 crores. You applied for a loan of 10 crores and you are initially going to open 100 cake outlets in your city. And then you will spread. And then you will spread. So now you should know the formula to make the tastiest cake in the world. Am I right? You should now create a formula to make the tastiest cake in the world. And tell me, what are the X factors you need to optimize now? And I will tell you the output. The output is the cake must be tastier. The cake should be soft. And your cost should be less than certain amount. It can be any amount, right? You can, so that the price of the cake, can be fixed. So there are three outcome. Multiple variables you wanted to optimize. Multiple variable you want to optimize. You can optimize them one by one. You can optimize them simultaneously. If you want to optimize them simultaneously, this is called a multivariate analysis. Let us do it one by one. Now, first one, the taste. Now tell me, how will you measure the taste of a cake? Do you have a measurement system? Do you have a measuring equipment? Or do you have a robot which can eat your cake and then give you how much taste it is? Come on, here you can participate. How to check or how to measure the taste of the cake?
Depends on its sugar level.
Depends on the sugar level. That is X factor. I'm talking about the Y factor. The taste. I prepared a cake. I want to know how taste it is to my customer. Now tell me, how can I know it?
So getting a feedback.
Exactly. I'll make some sample piece of cake, or I will cut my cake into pieces and give to each one of you and ask you to taste. And then I will also ask you to give a feedback. On a taste score of 100, how much will you give it? Since you tasted the world best cake, you might give me a better rating. If your rating is above 80, then I am satisfied. I will proceed with the formula. If you give me a rating below 80, I will rework and try to improvise. All of you, do you understand? So this is the goal now, as far as the taste is concerned. Exactly, voice of customer. Feedback. But now, which is the measuring equipment, measurement system? The questionnaire is the measurement system. Your questions and the options are the measurement system. AAA, questionnaire should ensure the error while fetching the information is minimum, less than 10%. Team accuracy should be more than 90%. So taste is something which is Y variable. Now tell me, the taste of the cake depends on the ingredients. All the ingredients are the X factors. These are the ingredients, I've shown here for your easy understanding. Look at the ingredients. There are many ingredients. The skill of the chef is also one of the factors. But I am not going to complicate by including all the factors in DOE. I will always consider critical factors, the challenging factors while conducting the DOE. In my scenario, in my company, the challenges are, I know the influence of adding egg is very crucial for the taste. Am I right? All of you agree? Influence of adding egg is very crucial for the taste. Butter, milk, the flour, the sugar. So these are critical factors. I know. Why do I call them critical? Because they have the major influence. Probably, the flour may have 30% influence. The milk might have 25% influence. The butter might have 10% influence. The egg might have another 20%. Sugar might have another 15%. Right? And the rest can be other factors. So these factors, I understand the influence is more. So they are considered critical factors. Now I need to optimize them. I need to optimize them. And there are some certain other factors. The humidity, the type of oven my restaurant might use in the future. I don't have power control. Tomorrow they might change the oven, isn't it? And the seasonal variation. These are all uncontrollable. The uncontrollable factors are given the name called noise factors. The controllable factors are here. They are called design factors. All of you understand the difference between design factor and noise factor? Design factor means you can control them. Noise factor, you cannot control. When in our training program, Six Sigma training program, right? And the topics, the tools, the choice of topic selection for discussion in the live session, all are controllable factors. We can do the best to ensure you turn out to be an excellent black belt. We are equipping you with some exam questions. We are providing you the material. We are providing you the recording. All are X factors, design factors. But there are certain noise factors. What are the noise factors? You get a sudden meeting from your company. You are not available here. Am I right? We can't work on those things, isn't it? We can't ask your company not to conduct meeting. That is beyond our control. So that is a noise factor, right? And somebody is sick on a particular day. He has not come to the training, or he has come to the training but not participating because he is sick. And again, the factor is noise factor. Do you understand? But still, the effect of the noise factor, your system should minimize. Are we taking care? Suppose if you are not present for 1 hour, how we are managing? We are providing recordings. We are again having some extra sessions. So this is how we make our system robust. Similarly, any product, any service, there will be noise factor. Hope everything is clear to everyone, right? Now, next step. Decide the range of investigation. Egg means for 1 to, where is the flour? Flour is X4. For 1 to 1.5 scoop, a kind of measuring cup. For 1 to 1.5 scoop of the flour, this is the range for the flour. And now, how many eggs I can add? I have a doubt only between 2 and 3. Whether 2 will do or 3 will do. That is only my doubt. I know 1 will be very less, more than 3 will be very high. So range of investigation is 2 to 3. All of you understand here? So there is a factor right now I'm dealing. The factor is number of eggs. There are 2 possibilities. Either I can add 2x or I can add 3x. This is called level. How many levels are possible now? Either I will add 2x or I will add 3x. So how many levels are possible now? 2 levels. 1 factor, 2 levels. Now, coming to butter. For the same situation, I can add 1 stick of butter or 1.25 stick of butter. Again, how many levels? 2 levels. Third factor, milk. I can either add 2 cups of milk or I can add 3 cups of milk, which means again number of factors is 2. Flour. Flour is between 1 to 1.5 scoop. Either I will take one scoop of flour or 1.5 scoop. And finally sugar, 1 to 2 spoons. Either I will add 1 spoon or I will add 2 spoons. So this is called range of investigation. You can always choose the center value also. If I choose the center value, let us say between 2 egg and 3 egg, let us say I am also experimenting 2.5 eggs. Now how many levels? Levels have now increased to 3. Do you understand? If the options are 2 and 3, 2 levels. If the options are 2, 2.5 and 3, now how many levels? 3 levels. Right? So levels are decided by you. according to the requirement. So in this case, there are 5 factors. All factors, only 2 levels are chosen. Now decides the level within the respective range. It is up to you. You can just experiment 2 and 3, or you can also experiment 2, 2.5 and 3. You can also experiment 2, 2.25, 2.5, 2.75 and 3. All of you, do you understand what I am talking? When I say 2 and 3, how many levels? 2 levels. When I say 2, 2.5 and 3, how many levels? When I say 2,
3 levels.
3 levels.
3 levels.
So levels by you. But here I am choosing only 2 levels, which means low, high. That's all. All of you, please understand one thing here. Mathematically, 2 levels will help. 2 levels will help if the relationship is linear. 2 levels will help if the relationship is linear. You remember, we studied linear relationship, y equal to mx plus c. If we know the relationship is linear, 2 levels are sufficient. How do I know the relationship is linear? Correlation, scatter diagram, regression. If relationship is non-linear, non-linear means curve. If the relationship is non-linear, it is not straight line, it is curve. Can you draw the curve with just 2 points? If I ask you to draw a curve giving you 2 points, will you be able to draw it correctly? Difficult. Now additional points are required, center points. Center points are required. Increasing the levels further can show you the path, isn't it? So if the relationship is linear, 2 points are enough, because with the help of 2 points, you can draw a straight line very easily. But if the relationship is non-linear, you need to go for higher levels. So some idea here. Now step number 5. Follow the principle of DOE. There are 3 important principles all of you must respect when you are conducting DOE. One is randomization. Another one is replication. Third one is blocking. Randomization means, now randomization is done to minimize the bias. You remember in Gauge R&R study, I suggested you to randomize the trial. People should not know what are they measuring. Don't tell them in advance. If you tell them in advance, then they will give the correct value. They don't work properly. Same way, randomize the trial. If you have to make 100 cakes, the order of making the cake for a different combination of the factors should be decided by you, not by the chef. This is called randomization. All of you, do you understand what is randomization? All of you, do you understand randomization? Please confirm.
Yes.
Yes, sir.
Yes. Right. So if there are 100 cakes, you need to create as a part of your experimentation. 100 sample cakes you want to create, and the order of making the cake is only known to you. Formula for cake number 1 is only known to you, and then all else have they just have to follow your instruction. That's all. Otherwise, what will happen? You might have a formula and somebody will be doing something else. That should not be the case. How much temperature and everything is decided by you. And then replication. Replication is now repeating the experiment with the same kind of settings. Replication is repeating the experiment with the same kind of settings, slightly at a later time. I have a formula. I prepare a cake in the morning. I will have the same formula, prepare one more cake in the evening. The cake what I made in the morning, the cake what I made in the evening are exactly same. Then what is the difference? The first cake is made in the morning, the second cake is made in the evening. This is called replication. All of you understand what is replication? Right? So now the replication is, I simply repeat the experiment with the same settings to the extent possible. I keep the same settings. I am checking whether I am getting the same result one more time. So replication will help you to get an estimate of the measurement error. So replicate to estimate the experimental error. Do you understand? If I repeat an experiment, I get different readings. Do you think your readings are accurate? There is an error, which is called experimental error. And then blocking. What is blocking? For experimentation purpose, I have to make 100 cakes. But I have a facility to make, let us say you have your kitchen. In your kitchen, how many people can work? Only you and your wife can work. In your kitchen, only you and your wife can work. So you are a chef and your wife is another chef. And now for making one cake, how much time do you consume? 1 hour at least. 1 hour. So in a day, you can work for 8 hours. You can work for 8 hours. So let us say you are working for 10 hours. So in 10 hours, how many cakes you can make? Some calculation. Come on, answer this question. So 10 hours, how many cakes you can make in your kitchen? One cake, 1 hour, and you are working for 10 hours. And there are 2 chefs.
Cakes.
And you will make 10 cakes, and your wife will make 10 cakes. So totally
20 cakes.
3 cakes you can make. So the answer is 20. And how many you have to make totally? 100. So you have to continue your study for next 5 days. Do you understand? And every single day you are making 20 cakes. Whether you are making the cake in your kitchen or you are making the cake in your restaurant. Your experiments will continue for 5 days. This is called blocking. Every single day is a block. Every single day is a block. Day 1 is block number 1. Day 2 is block number 2. Day 3 is block number 3. Day 4 is block number 4. Day 5 is block number 5. All of you are with me on blocking?
Yes.
Very good. And now within the block, you should randomize. Because within the block, the chef is making 10 cakes. Chef number 1 makes 10 cakes. Chef number 2 makes 10 cakes. The order of cake making is again decided by you, not by the chef. The order of cake making is decided by you. The formula according to your choice. The order of experimentation is according to your choice, which is called randomization. This will minimize the bias. Because every piece of cake we produce is important to our success. We have to be very sincere in doing. For that purpose, we need to randomize. Right? And make sure replication also happens. All the 5 days should be homogeneous to the extent. All the 5 days should be homogeneous to the extent. Which means every single day you make exactly 20 cakes. Am I correct? Morning 5 cakes, afternoon 5 cakes. In day 2 also you maintain the same thing. Morning 5 cakes, evening 5 cakes. This is called homogeneous. The blocks are homogeneous, almost equal. But inside the block, there will be randomization. Hope the 3 important principles are understood. Randomize to minimize the effect of noise. Otherwise, there will be more bias. Randomize to minimize the effect of the noise. Replicate to estimate the experimental error. And block to minimize the bias as well as the error due to the noise factor. Step number 6, decide the design layout. 5 factor, 2 levels. Now the design is called 2 power 5 factorial design. What is 2 power 5? 2 multiplied by 2 again, no, 6 times 2. What is, 5 times 2. What is 2 5 times? It will be 32. Minimum 32 cakes have to be, produced if you are working on 5 factor 2 levels. Hope all of you are with me so far. And replication. If replication is 2, minimum 64 cakes have to be done. All of you understand the number of experiments? Number of experiments is minimum 32. How do I get it? 2 power 5. What is 2? Levels. What is 5? Number of factors. Level raised to the factors can give you an idea of the number of trials or the number of experiments. Step number 7, conduct the experiment. Actually produce the cake. Give the samples to your customer. To be very sure, give it to 2-3 customers. Same cake, give it to 2-3 customers and get the rating done. That is replication. Why are you giving it to 2-3 customers? Because you wanted to avoid the error. If there is an error, then that will reflect in the readings given by multiple customers, right? And now taste in 100-point scale recorded for all 32 cakes. Now analyze the data. Determine the optimum combination of the ingredients, which is the solution. Determine the optimum combination of the ingredients, which is the solution. Now predict at optimum combination. Predict at optimum combination. That is, you are developing an equation now, which is called a prediction equation. And then you are actually piloting the optimum combination. And now you are seeing the results in real time. These are the steps in DOE. Hope all the 11 steps are understood by all of you. Please confirm. You have understood, right? All of you.
Yeah.
Yep.
So I have already explained blocking. Why are we doing blocking? We are doing blocking to minimize the effect of the noise factor. What are noise factor? Uncontrollable factors. Uncontrollable factor. Right? If the chef is working in a daytime, he is making cakes. If the chef is working in evening time, then also he is making cakes. Do you think the chef will be more energetic in the daytime and less energetic in the evenings? Am I correct? Yes or no?
Yes, sir.
Yes.
So when you are conducting the experiment, you must have provision to make cakes in the daytime as well as in the evening time, because the tiredness, the energy level of the chef is an uncontrollable factor. That should not become a reason for the failure of your business. So you are carefully conducting experiments. One cake in the daytime, one cake in the evening time. Isn't it? So this is how we see to that the effect of the noise factor is minimum. Similarly, replication, similarly, randomization. Moving on. There is main effect. I have already talked about. There is interaction effect. I already talked about. I'll give a different example. In order to understand the main effect and the interaction effect. Imagine you are taking a painkiller medicine. What are you taking? And don't consider the example that is written on the screen. Imagine you are taking a painkiller medicine. When you take a painkiller, the painkiller medicine gives you a complete relief for 2 hours. Let's say you have some back pain or something. You take, it's intolerable, so you are taking a painkiller. So 2 hours complete pain relief. So what are you doing? Doctor is advising you to take the medicine, every 2 hours or every 3 to 4 times a day. Now the pain relief of 2 hours is called the main effect. So what is the main effect of the painkiller now? Pain relief for 2 hours. Now what happened? Another day, you have to take the painkiller along with an antibiotic. Now the doctor is giving you an antibiotic A for some other purpose. Now you are taking 2 medicines together. Painkiller also you have taken, antibiotic A also you have taken. And now the painkillers works perfectly fine. Now also the painkiller gives same 2 hours of pain relief. Now tell me, is the antibiotic A disturb the function of painkiller?
No.
That means the antibiotic and painkiller do not interact. That means presence of antibiotic is not influencing the function of the painkiller. That means there is no interaction with the factors. You can take both the medicines together. Now, another day, doctor is advising you to take antibiotic B along with painkiller. Now you have taken the painkiller along with antibiotic B. And now the antibiotic effect is reduced to the painkiller's effect. The painkiller's effect is reduced to 1.5 hours. Always it gives 2 hours of pain relief. But now what happened? 1.5 hours of pain relief. What do you think? Why the effect has come down? What is the reason? Why the painkiller is same? But now it is giving only 1.5 hours relief. What happened to the 30 minutes? How it can come down?
Maybe the antibiotic effect has been influencing that.
Exactly. The antibiotic has pulled down. The antibiotic has suppressed the effect of the painkiller. Can I now say the antibiotic and the painkiller interacts? Can I say they are interacting?
Yes,
And the interaction effect is positive or negative for you?
negative.
So what will be the approach you approach now? Will you allow the antibiotic B and the painkiller to interact inside your body?
No.
You will probably now advise the patient, don't take the antibiotic and painkiller together. Take the antibiotic separately after 1 hour. Do you understand now?
Yes.
We are not only working on the main effect. Painkiller has got a main effect. Antibiotic has got a main effect. I need main effect, but I don't need interaction effect. Now I'm giving you an idea how to, minimize the interaction. Never allow, the antibiotic B or never allow the patient to take the antibiotic B while taking the painkiller. Separate them with 1 hour. Similarly, pressure and temperature can interact. All of you agree? Pressure and temperature can interact.
Yes.
Yes, sir.
The speed and the composition can interact. So you need to be very careful. Though there are 3 factors, there can be more than 3 effects. Though there are 3 factors, there can be more than 3 effects. And for 3-factor scenario, there can be 4 interaction effect. I told you, A, B, C are the factor. There will be effect due to A, effect due to B, effect due to C. We call them as main effect. There is a possibility of interaction effect called AB, interaction effect called BC, interaction effect called CA, and one more interaction effect, 3-level interaction called ABC. Now, totally how many effects? 7 effects. 3 factors, 7 effects. Imagine how complex will be the scenario if you consider the interaction also. So that is why design of experiment is very helpful. But it is a costlier tool. Please understand, it is a costlier tool, time consuming, more effort is required, generally adopted by researchers. If the problem you are addressing really requires DOE, please use it. Just because you have the DOE in your packet, don't try to explore it. There has to be a clear necessity. Then only you should go for it, right? So we know the block, and there are 4 types of design: factorial design, response surface design, mixture design, and Takeuchi design. Factorial design means that allows the simultaneous study of the effect that several factors may have on a response. We simply do experiment for all the factors, for all the levels, and all possible combination of the factors and levels are studied. That is called a factorial experiment. That is called factorial design. For 5 factor with the 2 levels, how many experiments are required? 2 power 5, 32. You conduct all the 32 experiments. Now your design is factorial design. Now your design is full factorial design. All 32 combination you are actually experimenting. I only do half of the 32, which is 16. Now my factorial design is half factorial design. All of you, do you understand what is full factorial and what is half factorial? I only conduct a small part of the experiment. I don't want to do all 32. I will only randomly do 8. I will only randomly do 8 experiments. Now the design is called partial factorial design. It can be full, it can be off, it can be partial according to the situation. Now response surface design. When to go for response surface design? When you include center point, your design will be called response surface design. Let us say you are studying temperature. Temperature in a boiler can vary from let's say 500 degrees Celsius to 600 degrees Celsius. Your boiler temperature generally varies from 500 to 600. Now you are studying the influence of the temperature at lower value as well as at higher value. What is the lower value? 500. Higher value 600. Now you are studying only two levels, low and high. If you include one more level, medium, between 500 and 600, you are adding one more level, 550. Now your design is suitable for response surface design. The relationship between X and Y can not only be seen as a line, it can be seen as a curved line. With the help of the curved line, you can even develop a curved surface. Your solution is nothing but a point on the curved surface. Now, all of you, please answer my question. You all have got a house. And the house has got a roof. Am I correct? Yes or no?
Yes, yes.
Yes, sir.
Your roof will be flat or curved. The roof of the house, will it be flat or will it be curved?
Flat.
It will be flat. And now every single day sunlight is falling on the roof. You want to find out which point of the roof receives maximum sunlight. And so inside your room, you are going to put some air conditioner in that location. Right? You understand the purpose now? Now you have got a flat roof and now the sunlight is falling on all the points on your roof. Now you need to find out the point where the temperature is high. Will you be able to find out which point will acquire more sunlight, will have more heat?
No.
Will you be able to find out or not?
No, sir.
Why? Why don't you go to the roof? Why don't you stand in all the points, in all corners, come to the center, you mark points. Wherever required, you go and stand. Will you be able to get a sense of the heat? Yes or no?
Yes, sir.
So you get an idea where the temperature is more. Similarly, if your roof is curved, let us say it is like a dome, the roof is curved. Now, where the temperature will be high? Obviously on the top, isn't it? Because the top point will be closer to the sun. So you need to know whether the surface is flat or curved. If the surface is curved, which means the relationship is curvilinear, you must necessarily include center points. If required, additional points. What is the center point with the help of a temperature? 500 is the lowest, 600 is the highest. Now, what is the center point?
550.
550. Unless and until you include 550, you can't figure out whether the relationship is linear or non-linear. You will simply assume relationship is linear. You think that your house roof is flat, but actually it is a dome. If you want to know the curvilinear relationship, you must necessarily include center point. If needed, include additional point so that you exactly know the profile. Whether the profile is circular, elliptical, parabolic, hyperbolic, all that you can find out. This kind of statistical and mathematical knowledge is important if you are really working on a complex issue. But don't worry, you don't have to break your head too much because softwares are there. You just have to respect the principles. We are teaching you philosophies, we are teaching you principles. Simply follow them. Replicate, randomize, block, and have the factors, have the levels, include the center point. Automatically, you will be traveling in the right direction. Now, another design called mixture design. We are playing between Y and X. Y is output, X are input. For making coffee, right? Coffee taste is Y, but coffee powder is input, milk is input, and sugar is input. But what is temperature? Do you think temperature is also a physical input? It is not a physical input. It is process parameter. Am I right?
Yes.
Yes, sir.
You can optimize the inputs. You can also optimize the process parameters. Now your design is called mixture design. Design is called mixture because you are not only optimizing the input, you are also trying to optimize the process condition, temperature, pressure, skill level. That's called mixture design. Now, Takuchi design. I find this subject costlier. How you have every single day 32 cakes and then 10 days 320 cakes. So my wife will send me out if I make so many cakes unnecessarily, isn't it? So it is costlier. So I need to have some technique of minimizing my expense. That has been provided by one expert, a gentleman called Takuchi, Jenichi Takuchi. Again, he is Japanese quality guru. So the Takuchi's last function, we also spoke about it, isn't it? So he gave what do you call an idea by which you have to conduct only selected experiment. Yes, you have to conduct only selected experiment. Don't do all experiment. There are 160 experiments required, but he is advising you to conduct only 16 experiments out of 160. Now your cost will come down? Definitely come down. But still, you get quality information. You get quality information, you will be able to achieve significant improvement. Such a design is called a Takuchi design. He used a concept called orthogonal array. He used a concept called orthogonal array, which is again a mathematical concept. All of you could have studied in matrices, and using which he figured out, he nailed down, he gave you a guideline to hand pick certain experiment, which is called a Takuchi design. Now you have to go step by step. Don't jump to the complexity. First, you master factorial design, and then you can slowly move on. Once, if you are thorough here, factorial design, these are all simple. Because factorial design is the maximum number of experiment. Takuchi only few experiment, but the analysis is same, right? So we are going to master the factorial design. And now see here, there are two factors, and each factor has got two levels. Now, what will be the total number of runs or total number of experiments? 4. Either you go for 2 power 2 or you multiply 2 into 2. 2 is level, 2 into 2. Now, there are two factors. One factor has got 2 level, other factor has 3 level. Now, total number of experiments will be 6. How do I get it? 2 into 3. Now, tell me, there are 5 factors. First factor, 2 levels. Second factor, 3 level. Third factor, 5 level. Fourth factor, 2 level. Fifth factor, 3 level. Now, what will be the total number of experiments? What will be the total number of experiments? Multiply all the levels. 180 experiments. If you conduct all 180 experiments, your design is called factorial design, full factorial design. You conduct only half of it, your design is called half factorial design. You conduct only a small portion of it, your design is called partial factorial design. Takuchi design is actually a partial factorial design. Right? And now you also need to understand balanced design and unbalanced design. Balanced design means the number of runs at each and runs at every possible combination of factors and levels is maintained constant. Temperature 60 degrees Celsius, temperature 80 degrees Celsius. So how many levels per temperature? 2 levels. At 60 degrees Celsius, I have done 3 experiments. At 80 degrees Celsius also, I do 3 experiments. Now my design is balanced. At 60 degrees Celsius, I have done 3 experiments, but at 80 degrees Celsius, I have done only 2 experiments. Now my design is unbalanced. Hope all of you understand. For balanced design, you will be using the balanced ANOVA for analysis. If the design is unbalanced, we will be going for unbalanced ANOVA. All of you are with me so far?
Yes.
Please confirm. Yeah. I hope everyone is able to travel with me. Now, the difference between orthogonal experiment and factorial experiment. So I have been talking about orthogonal, right? And see here, look at this cube. How many corners here in the cube? 27 corners. Every or 27 points, not the corners, 27 points. Every point represents an experiment. How many factors? 3 experiments. They are represented along x-axis, y-axis, z-axis. And every factor has got 3 levels: low, center point, medium, and high. 3 factor, 3 level. Totally how many experiments? 3 to the power 3. What is 3 to the power 3? 27. Can you see all 27 points here? Can you see all 27 points here?
We can see, but we couldn't able to count them.
3 factors, 3 level, 3 power 3. How much? 3 into 3, 9. 9 into 3, 27. These 27 points are shown in the form of a cube. This is your experiment. Very simple. Every single point has a combination of the factor. For example, here, this point, all the 3 factors are at the medium level. Am I correct here? All the factors are medium. This is the point where x is low. Isn't it? Low, medium, and this is the point where x is high. Isn't it? But this is the point where your x, y, z all are medium. So likewise, now all the experiment if you do, it will be full factorial. You hand pick certain experiment and do it. But how to hand pick? Takuchi has given you a concept, which is called orthogonal array. Look here, he out of the 32, he selected only how many experiment? 9 experiment. But with the help of 9 experiment, you can still arrive on a solution. These 9 experiments are listed here. While after hand picking the point, you can check whether the array, this is called array, whether the column A, column B, column C, together is called an array. This array is considered orthogonal. Look here. Consider 2 rows, A and B. Do you see 1, 1 here?
Yeah.
Factor A, level 1, level 2, level 3. Factor A has got 3 level, low, medium, high, or 1, 2, 3. Similarly, factor B has got 1, 2, 3. Factor C has got 1, 2, 3. Now I take 2 columns, A and B. I see 1 and 1. You will have similar combination for B and C also. Do you have 1 and 1 for B and C also?
Yes.
Am I right? If you select in that manner, if you select in that manner, the array formed is called orthogonal array. Second row. What is the combination for A and B?
1 and 2.
Do you have 1 and 2 somewhere else between B and C? Which row contains 1 and 2?
5th row. 4th row.
4th row. Now the array is called orthogonal array. That's all. You got the point. Now the array is called orthogonal array. This approach is helping you to reduce 27 experiments to just 9 experiments. This is called Takuchi's design. Right? You can read further later on. And now we are going to understand the advantage of the robust design, which is again a concept by Takuchi. What is robust? Robust means minimizing the effect of the noise. Minimizing the effect of the noise factor. Now see here, egg, butter, milk, flour and sugar. These are design factors. But the type of oven, the season, these are noise factor, uncontrollable factor. Now I have done the experiment in considering the noise factor also. But only problem is noise factor I cannot control, but they will keep changing. But I have done the blocking, very carefully to minimize the noise effect. Now see here, 5 factors, 2 level each. Totally how many cakes I have done? 32 cakes. Am I right? Can you see 32 readings? Can all of you confirm? Can you see 32 readings now?
Yes.
Now the reading represent Now the reading represent taste score of the cake. What is your expectation requirement? Taste should be minimum 80. Now, which particular combination of the egg, butter, milk, flour and sugar you will choose? Will you choose this one, which is, where is the cake taste, taste is very high? 89. Can I go for this combination? Second row number 2.
Yes. Yes.
But look at the variation here in this combination. I have repeated the experiment 4 times. I have repeated this combination 4 times. One time I got 89. Look at one time. Are you okay with this variation? Which means even if you use the formula, your cake will be extremely good sometime, can also be bad sometimes. Do you understand?
Yes.
But look at the 4th row. When I use this combination, irrespective of the, see why the variation happens? Effect of the noise. Do you understand now? The noise factor can pull down the taste because noise is something which you can't control. But even if the noise factor is playing, row number 4 always giving you a taste of more than 80. Am I correct here?
Yes.
Now your design is robust enough. Now your design is robust enough to even manage the uncontrollable factor. Uncontrollable factors are factors we have poor control over them. But we are able to control them through the controllable factor. So controlling the uncontrollable factors by effective handling of the controllable factors is called robust design. It's called robustness. Hope the concept of robustness is clear to everyone. Now this is the solution. This is the solution. So we will proceed to understand, the what you call the main effect and the interaction effect with the case study. So what I will do is I would like to give you a small break because you have learned a lot of principles now. So I just want to prepone your break, and so that we can come back and then continue so that you can grasp very well. So I am doing a small blocking here. I'm stopping here and then we'll continue, right? So we are slightly taking the break little in advance. Because the intention is, you should understand this tool very clearly. There will be calculations which I will be explaining. So shall we continue after 10 minutes?
Yep, okay.
So right now we are going to continue with the learning, right, of the DOE, design of experiments, and we are going to analyze, after conducting the experiment, how to analyze. Imagine there is a square here, right? This square represents the outcome of your experiment. First experiment produced this output. Second experiment output is this one. Third experiment output is this one. Fourth output is this one. If there are 4 experimental reading, which means, what is your experiment? Your experiment is based on 2 factors and 2 levels. That is why you have 4 outcome, isn't it? 2 power 2 or 2 into 2, right? So this is factor A. This is factor B. Factor A, how many levels you have? Low level and high level.
I love.
Low is represented as minus, high is represented as plus. When both factors are low and you did the experiment, the result is 10. When A is high, B is low, the experimental reading is 30. When factor A is high, B is also high, what is the output? 40. When A is low, B is high, the output is 20. I want to visualize the output of the 4 experiment in a graph called interaction graph. This is called interaction plot. In order to plot the interaction, you require x-axis. X-axis should represent the level of the factor A. Y-axis will represent the value of the experimental outcome, which is response, the Y variable. And now when the factor A is low, factor B is also low. What is the outcome? 10. Or the experimental output is 10. A is low, B is low. Can you see 10, all of you here? Please confirm.
Yes.
You can also mark that point in your graph sheet. Now I am increasing A to high, B at low. When A is high, B is low. When A is high, B is low. What is the experimental output?
20.
Not 20, you're wrong. A is high, B is low. A is high, B is low. What is the output?
30.
30. So A is high, B is low. Can you see the 30 here? This point? Please confirm. You got this point, you got this point. Now you connect the points. Connect both the B minus. You are now visualized the readings where A is varying from minus to plus, but B remains at minus in both conditions. So this graph is visualized. All of you are clear with this? Now, once again, let us vary the A from low to high. A is low, B is high. Tell me what is the experimental output from the left side diagram? A is low, B is high. What is the experimental output? $20, right? A is low, B is high. Experimental output is 20. Can you see 20 here? Yes, right?
Yes.
Simply assume. Now A is high, B is also high. What is the experimental output? 40. Can you see here the 40? And now connect the B plus and B plus. Now you have drawn a line connecting both B minus and connecting both B plus. Now tell me what is the nature of the graphs, or the graphs are parallel or intersecting?
Parallel.
If the graphs or if the lines are parallel to each other, there is no interaction. You can now make a conclusion that these factors do not interact. This is like your painkiller and antibiotic A. You can take them together. You can take them together because there is no interaction. If there are two factors and if there is no interaction, how many effects will be there? Only two effects. Main effect of A, main effect of A, main effect of B. But if there are two factors and there is interaction, how many effects will be there? Main effect of A, main effect of B, and third one, interaction effect called AB. Hope all of you understand my language. Now I go to the next example. Let us create the same graph with a different experimental output, right? Because these are different factors. Now A low, B also low, this point. A high, B low, this point. I have drawn the line. Now A is low, B is high. A is high, B is high. Now I have drawn this line. Now looking at the lines, tell me, are the lines still remain parallel or intersecting?
It's intersecting.
Now the factors interact. Now tell me how many effects will be there in this case? How many effects will be there? 3. Very good. Anand is good. He is picking up very fast. There will be main effect due to A. There will be main effect due to B. There will be interaction effect called AB. Now Anand's result can be much more accurate than anyone else because he knows the presence of interaction. He will go to the extent of controlling the interaction. If the interaction is positive, he will allow the factors to interact. If the interaction is negative, he will minimize the interaction so that his results can be great. All right. Oh, all right. This time it is Sagar. Congratulations, Sagar. Yeah, the answer. Sagar could pick up fast. Very good. Good competition. And now the yield. Now we are taking a case study. I only have three, 4 slides further, but very important. The yield of a chemical reaction was thought to be a function of 3 variables, 3 factors. Formulation, F, mixture speed, S, temperature, T. An 8-run 2-level experiment was conducted based on the 3 factors. Because 3 factor, 2 levels. Now total number of experiments, 2 power 3. 2 power 3 is 8. And these are the 8 experiments. Random. In order to randomize, I have generated the random number. And formulation, I have 2 formulation. Formula A, formula B. Speed, I have 2 speed, 60 RPM, low speed, and high speed is 80 RPM. Temperature, low temperature is 70, high temperature is 82. All of you understand the 3 factors and the corresponding levels. and totally 8 experiments. This is random order and this is standard order. Now you have to create something called a design table. The design table, you have to declare the levels for all the 8 experiments. For the first column, I suggest, the formulation, you have only 2 options. What are the 2 options? Either A or B. You can also use number. A means -1, B means +1. 4 minus 4 plus. You put 4 minus 4 plus because I have 8 experiments. Half of the time I will retain the formulation A, half of the time I will retain the formulation B. 4 minus 4 plus. Now for the mixture speed, I have 60 RPM, 80 RPM. 60 means -1, 80 means +1. Can you see double minus double plus, double minus double plus? Double minus double plus, double minus double plus. A pattern. Now for the third column, temperature, I have 2 options, 70 and 82. Go for minus plus, minus plus, minus plus, minus plus combination. Single minus, single plus, single minus, single plus. Idea is the combination is never repeated. Can you see all minus? You are seeing only once. It is not coming again. That means all possible combination of the factors is now listed. The experiment is conducted. Experimental output is recorded. What is the experimental output? Can one of you tell me? What is the output here? What is the output here? What is the output here? Output here is chemical, the yield of the chemical reaction. The number is representing the yield of the chemical reaction. So the yield is recorded. Now I want to optimize it. Optimizing means the level for F is finalized, S is finalized, T is finalized. That is the outcome of the experimentation. And now, in order to understand the calculations behind the design of experiments, in order to understand the calculations behind the ANOVA, you must make some calculation yourself by your hand. You have to do it. There are 8 readings, right? How many of you can calculate grand total? Grand total is sum of the response. Please confirm. Will you be able to calculate the grand total of the experimental output? It is an easy calculation, right? Say yes.
Yes, yes.
Which is nothing but simply sum of all the 8 outputs. Very good. Now you need to calculate something called correction factor. Correction factor is grand total square divided by the number of experiment. Number of experiment is 8. Grand total is here. Square it, divide by 8, you get correction factor. Now you need to find out main effect. Main effect is nothing but the average effect when the factor is at high minus the average effect when the factor is at low. For example, consider formulation. A is low, B is high. How many readings you have when the formulation is at high? How many readings you have? 4 readings. Take the average. And formulation is low, as A. Now, how many readings you have when formulation A is maintained? 4 readings.
4
Can you
readings.
take the average?
4.
Now take the average. You have 2 average. Average when formulation is B, average yield when formulation is A. Find out the difference. The difference is due to the main effect of the formulation. All of you understand my language? The average of the yield when formulation is B minus the average of the yield when formulation is A. The difference is nothing but the main effect of the formulation. So, average is nothing but sum divided by number of trials. Am I right? Average is sum divided by number of trials. Since you had 4 trials, you are summing up all the 4 output when the factor is high. You are dividing by number of trials. Number of trials is 4. And subtracting again by the sum divided by the number of trials. So nothing but average yield when the factor is high minus average yield when the factor is low. This is the formula for finding out the main effect. Hope everybody is clear. Now proceeding with sum of squared variation. This is a statistical measure which you need to understand. Sum of the squared variation. The variation is sum high minus sum low. Sum high minus sum low is squared divided by total number of trials. Sum high minus sum low is squared divided by total number of trials. Total number of trials or total number of experiments is how many? 8. Now calculate squared sum. What is squared sum? 8 readings. Each reading you have to square and you have to sum up. All of you understand how to calculate squared sum? Yes. Now, very important thing, total sum of squares. Total sum of squares is squared sums minus correction factor. Squared sums is here, correction factor is here. The difference is 876. This is called total sum of squares. Very, very important measure in ANOVA. In ANOVA, you can see this total sum of squares. And now percentage contribution is sum of squares of the factor divided by total sum of square. And this you will come to know automatically. An average response. You have 8 response. Average means total by 8. 1383 by 8 will give you 172.875. Please confirm. Have you understood all the mathematics here? All of you? Please confirm. Have you understood all the mathematics here? Simple maths.
Yeah, it is simple. Right.
Very good. Very good. Then we just proceed. And now the design table is expanded. Expanded means in addition to the factors, I have included interaction also. How many factors? 3 factors. Look at the 4th factor. The 4th factor, so far invisible. We only thought there are only 3 factors. We only thought there are 3 factors. But now since we are black belt, we now come to know there could be interaction. 5th factor, 1 more interaction. 6th factor, 1 more interaction. 7th factor, 3-level interaction. 3 2-level interaction, 1 3 2-level interaction, and 1 3-level interaction. Can all of you now please confirm? Can you see 7 factors? Can you see 7 effects?
Yes, yes.
Very important, right? And now, first factor, I am following a pattern just like last time. Double minus, double plus, double minus, sorry, alternate minus plus, alternate minus plus. Then double minus, double plus, 4 minus 4 plus. Once you follow this technique, you can fill up the entire table. Now TS will be plus. Why? TS means
Minus into minus.
T is minus, S is minus, minus into minus plus. Same way for TSF, all 3 are minus. Minus 3 times will give you minus. Similarly,
Yes.
you can now fill up entire table. Now, by fixing the levels for the factors, the levels for the interaction is also fixed. Interaction is high here, interaction is low here. Do you understand? 3-level interaction is low here, 3-level interaction is high here. You can control the interaction by controlling the factor. All of you understand my language now? You can bring down the interaction to minus. You can increase the interaction to plus. Can you see minus and plus happening for interaction also?
Yes.
If you know interaction is doing good for you, make it plus. If you come to know that interaction is giving negative results, make it negative. That's all. Very simple. And now coming to the calculation.
The y is the
Factors.
manual. Sorry, the y is the numerical which we fix it. Correct. It is
Y are the experimental outputs. In this case, yield of the chemical reaction. The value is written in the last column.
So it depends on the case to case. It will vary.
Yeah, see, in this case, chemical reactions yield. In your case, it could be strength of the material. It could be your turnaround time. It could be your travel time, whatever it is. It could be your blood BP level, sugar level. So we are trying to optimize a Y variable. Whatever is the Y variable, we have conducted experiment. And that experimental output, 8 output indicated in the last column, Y. Now, all the 7 factors are highlighted here. People generally think there are 3 factors, but we now come to know there are 7 factors. Now, this factor is kept high at 4 experiment. Same factor is kept high at 4 experiment. When the factor is high, there are 4 readings. For example, when the temperature is high, what are the outcomes? Can one of you read out the outcomes of the chemical reaction yield when the temperature is high? What are the output values? Can you read out from the column Y? I want the readings when the temperature is high. What are the readings?
695, 682.
No. You are just reading out from my answer. I am asking you, I'm expecting steps. What are the experimental outputs? See here, experimental output is Y column. What are the values generated when the temperature is high? Temperature is high. First output is 166. Next temperature high, the output is 160. Again, temperature is high here, 187. And last one, 182. Can you see them highlighted in green color?
Yeah.
There are 4 readings. There are 4 readings. These readings are obtained when the temperature is high. Can you sum them up? That is 695. All of you are with me? All of you are with me? You have to do this for all the factors. You have to do this for all the factors. Now, sum of the experimental output when the temperature is low. When temperature is low, what are the readings? First reading is 164. Next reading is 161. Third reading is 184. Fourth reading is 179. Now the readings are highlighted in no highlight, white color. Can you sum them up? That will give you 698. All of you please confirm. Do you now understand how do you get 698, 695 and 688? Yes? Yes or no?
Yes.
Yes. And now find out the difference. Find out the difference. The difference is 7. Divide by the number of readings at each level. How many readings you have at each level? At high, you have 4 readings. At low, you have 4 readings. So divide by 4. The 1.75 is the main effect of temperature factor, temperature T. The main effect of T is calculated to be 1.75. This is how you need to calculate the main effect. Same way calculated for all the factors. Now del square. You simply square the del. Del is 7. Del square is 49. Del is minus 19. Del square is 361. You understood this. Now del square divided by 8, which is called sum of squares. Which is called sum of squares. The sum of squares is del square by 8. Del square is here. Divide by 8. Now you square all the sum of squares, which is called total sum of squares. You remember I explained something total sum of square in the previous slide. How much is the total sum of squares?
876.
If you sum all these squares, are you getting 876?
Oh, you get it.
That's all. Either you use the formula or do it this manner. Now you need to figure out percentage contribution of the effect. Effect is nothing but variation in the output. Am I right? Effect is nothing but variation in the output. Variation can be positive, variation can be negative, right? Anyway, it is variation. So that is why I have squared. That is why I have squared, which is called sum of square. Total variation is this much. Out of the total variation, how much T is contributing? 6 divided by 876. 6 divided by 876 is 0.69. 45 divided by 876, 5.1. 820 divided by 876, 93. Now the percentage contribution is found to be this much. It is written. Now I understand only 2 effects have contribution more than 1%. There are remaining 5 effects. The contribution is less than 1%. I am going to ignore the factors that have less than 1% effect, because 1% effect is nothing. So I am simply ignoring. So in my opinion, these 2 factors are critical. These 2 factors are critical. This is what you are trying to figure out in ANOVA. So now with the help of the calculations, I am creating a table which is nothing but ANOVA table. All of you know ANOVA table, right? Analysis of variance. First column in ANOVA table is factors. What are the factors? S and F. Only S and F is coming because yes, only S and F have significant contribution, more than 1%. Yes, this is called significant contribution. Now S and F, all remaining factors are now ignored. So they are represented as error. The effect due to all the other factors we are ignoring. This is called as error. Now sum of squares for factor S. What is the sum of square for factor S? How much it is? Go back. How much is the sum of square for factor S? Please read out.
49.
45. That is written here. Similarly, sum of square for factor F. How much it is? 820. That is written
820.5.
here. All remaining. Before all remaining, you fill up this 876. 876 minus 820 minus 45 will give you 11.625. The reason for the variation of 11.625 we cannot explain because we have ignored. That is called error. The variation which we cannot explain in our experimentation is called error. This is written as error. Now degree of freedom. What is the formula for degree of freedom? Level minus 1. For factor S, how many levels are possible? 2 levels. 2 minus 1. 1. 1 is the degree of freedom. Similarly, for formulation, how many formulation? A and B, 2 level. 2 minus 1, 1. Total degree of freedom. Totally, how many experiments you conducted? 8. 8 minus 1, 7. 7 minus 1 minus 1. That will give you error degree of freedom. All of you understand the third column now?
Okay.
Now fourth column. Sum of square, mean sum of square. Mean sum of square means sum of square divided by degree of freedom. This is what Minitab is doing. Sum of square divided by degree of freedom. 45 by 1, 45. 820 by 1, 820. 11 by 5, 2.325. All of you understand this one? You don't have to calculate here. Only 3 effect. And now you need to calculate something called F score. You all know G score, isn't it? G score is X bar minus mu divided by sigma. X bar minus mu divided by standard error of the mean. Same manner. See, G score is calculated based on the average. But F score is calculated based on the variance. G score is calculated based on the average. F score is calculated based on the variance. Now the F score is nothing but for mean sum of squares of the variation divided by variation due to the error. Mean sum of squares of the variation. What is the variation produced by the factor? Yes. We are dividing it by the variation due to the error. So the F score for the factor F is 19. 45 divided by 2. Are you getting 19? You are getting 19. Similarly, the F score for factor F is 820 divided by 2.3. This is 325. 820 divided by 2.325, 352. Now, you must see, remember in our hypothesis testing, we converted the G score into p-value. Finally, we converted everything into p-value, isn't it? You can convert the F score into p-value. All of you right now, you can convert. All that required is an Excel file. Go to an Excel file, go to any cell in the Excel, type this. Equal to, you just have to start with equal to F distribution, F dist. Open the bracket, F statistics. How much is the F statistics for factor S? 19.40. Type here. Degree of freedom for the factor F. What is the degree of freedom for the factor F? 1. Degree of freedom for the error. How much it is? 5. So F value 1 here, 5 here. Close the bracket, enter. That will throw the p-value. Can you see how the p-value is generated? All of you can do it right now. If you have an Excel readily open, similarly you generate the p-value. Now simply tell me, is this p-value more than 0.05 or less than 0.05?
Can you repeat once again, sir? Just calculate.
See, I just want you to use this formula. That's all to get the p-value. Go to Excel file, go to any cell, type equal to first. Type equal to and type the 5 letters, open the bracket, type the F score. In this case, it is 19.4086. Type the degree of freedom, comma 1. Again, degree of freedom for the error, comma 5. Every symbol is important, and you close the bracket. And you close the bracket, and then you enter. Excel will show you the p-value. Excel will show you the p-value. Now the p-value is 0.06. Same way. Now you just have to tell me, is this p-value more than 0.05 or less than 0.05?
Less than 0.05.
So less than 0.05, reject the null. So far your company is thinking that yes means, what is yes? Yes means mixer speed. Your company so far believed that mixer speed can range anywhere between 60 to 80 RPM. Your company is allowing your operator to set the mixer speed anywhere between 60 to 80. But the study is telling you that mixer speed is critical. So the result what you get at 60 is completely different from the result what you will get at 80. Do you understand? So the chemical process yield is not equal. The effect of the S at high is not equal to the effect of the S at low. So you have to optimize the S. You have to optimize the S. And see here, come here. S is here. What is optimization in this case? You need to improve the yield of the process, isn't it?
Yes.
Yield of the process you want to increase. And look here, S gives, when the S is high, the yield is more. Am I right? Sorry, when the S is high, yield is low. 682.
Low.
When the S is low, yield is high. So what is the relationship? Positive or negative?
Negative.
Negative. So when you want more yield, you must set S at low. S must be set at low. Mixture speed should be 60 RPM. So that the yield will be maximum. This is how the factor is optimized. You have kept only 2 levels. You can keep 3 levels. You can be more realistic now. And now solution is set the S at low. That's all. Now coming here, again p-value is low. I want more yield. I want more yield. So I am going to take a call for the formulation. Formulation I have A and B. Coming to the formulation, yield is more when the formulation is high. High means formulation B. Low means formulation A. So B is the option. So formulation should be kept high. Look here. Set the F at high. Set the F at high. Set the S at low. The yield of the chemical reaction will be at the best. If you want to further optimize, find out some more points, some more levels. Don't just work with 2 levels. Find out the intermediate level. Between low and high, include medium. And now you will be, you will be much more realistic. You will still get better result. And this is how it goes. Now prediction equation. Always ANOVA gives the regression equation. Now we are going to write the regression equation ourselves. Regression equation or prediction equation Y equal to average response. How much is the average response? Tell me how much is the average response? 172. That is coming here. Can you see 172? 172.875 is the constant term in your prediction equation. The constant term in your prediction equation is nothing but the average response. Plus factor S. First factor X1. Next factor X2. In the place of X1, we have S. In the place of X2, we have F. And the coefficient of the factor is called regression coefficient. The coefficient of S is nothing but minus 4.75 divided by 2. What is minus 4.75? Can you see minus 4.75 here? Minus 4.75. Minus 4.75 is nothing but the main effect of the factor. The main effect is divided by 2. Why I am dividing by 2? The factor has got 2 levels. So I divide by 2. Now it reduces to 2.375. Similarly, for the factor F, what is the main effect for the factor F? 20.25. Divide the 20.25 by 2. Now you have 10.125. Now the prediction equation is written by yourself. This is a linear equation because there are no square involved. This is a linear equation. And this linear equation is, there are two factors. This is called multiple linear regression equation. So from the deciding of the factor, experimentation, till the regression equation, we have done ourselves manually. I'll share.
Sir, give me co-host.
So I'll share all these data files. You can calculate once for yourself, right? So that this is what you need to, this is how the regression equation is generated in Minitab also. So DOE can be used to optimize any X variable. Optimizing to the best. This is not trial and error. This is a systematic approach, right? And this is the purpose of DOE. So that's it from me about DOE. If there are any questions, you can ask me. Otherwise, thank you for your excellent participation, particularly during the DOE. So I'm sure you all gained the good knowledge about DOE. And now you just have to practice and you just have to know how to do the analysis in Minitab. That is an easy job. So our Checker sir will show you how you can analyze the data after conducting the experiment. If you have data in your hand, you can analyze the design of experiment using Minitab, right? So I request Checker sir to proceed further so that he can explain using Minitab.
Okay. Good morning. Good morning.